Hey y'all, today we have one last confidence interval to talk about. We're going to be talking about two samples and we're going to be talking about means, but this time we're going to be talking about paired means. So it's slightly different than when we have two means, and you'll see why in a second. So when we do a paired t-interval, what we're looking at is two groups that are not independent of each other. So one of our assumptions and conditions we have to make when we have two samples is that the two groups need to be independent of each other. Well, if they're not, if there is some specific relationship between the two groups, then it's important to do a paired t-interval rather than a two-sample t-interval. So, for example, if you're trying to learn something about spouses, Mrs. Pickard and I would have some sort of um, well, obviously we have a relationship, we're married, and so her data and my data should be put together because there's a lot of things in our lives that influence us both the same. So that would be an example where we would take the spouses, a group of one of the spouses and a group of the other one, and we'd want to pair them together. So we then have to find the difference in those two values in each pairing, and what we get is a mean. What we can do is calculate a mean. That's what this is. This is the mean difference. So we're no longer actually looking at two means. We're looking at one mean, and that mean is the difference from the two groups. The rest of this should look very similar. SD means like the standard deviation of differences. This should look like a one sample t-interval because it's the same format, but we get our mean and we get our standard deviation not from one sample, but from the difference of two samples. And so our assumptions and conditions, as they have been, are going to be very similar, but we need to make sure that we're now assessing the differences. So we do need to always get a random sample, either sample randomly or have random assignment. We need independence, but that independence exists in the differences in the groups. The groups are specifically not independent of each other. That's why we're pairing them. When we pair them and we find the set of differences, those differences need to be independent, or we need to have less than 10% of our population sampled. And that's usually how we assess that. The normal condition still is the same, but we analyze not each group, we analyze the differences in the group. So that's why I put that stuff in red. Same idea though, the larger the sample, the more we can accept skewedness in the histogram of the differences. So if you're making a histogram or you get a histogram, that histogram will need to be of the differences in the two groups. And then last but not least, you shouldn't do a paired t-test unless your data is actually paired, unless it makes sense to group data points from one group to another. So let's look at an example here. Take a second and just read through this problem. So we are assessing fuel efficiency of 316 cars and trucks. We're looking at their MPG, their miles per gallon, in a city driving session and setting, and in a highway driving setting. Typically, you get better fuel efficiency, more miles to the gallon in a highway setting because you're not changing speeds a lot. You're not having to stop and start. That uses a lot of gas. So typically, that number is larger. And of course, there's other factors for your miles per gallon, like the size of your vehicle, the size of the engine, things like that. So if we were going to compare a fuel efficiency of city and highway, it would make sense that we paired the city mile per gallon and the highway miles per gallon for each individual car, because those are going to be related. Something like a Toyota Prius used to be the prime example, but now we have a lot of really fuel efficient cars. But I'll use that anyways. If I'm going to compare a Prius and let's say a Ford F350, a big truck, I'm not going to want to compare the city miles per gallon of the Prius to the highway miles per gallon of the truck. Those two ideas are not comparable. So what I would want to do is pair my Prius's city and highway miles per gallon, and I'm going to find the difference in those two measures. I'll take my truck and I'll find the city miles per gallon and the highway miles per gallon, and I will find the difference. And if we did that for all 632 vehicles, 316 cars, 316 trucks, we found the differences in those two measures, we could create this histogram down here. This is a histogram of our sample of vehicles and the difference in their fuel economy for highway and city. And you can see it's skewed to the left, and they do mention in the problem that they have removed this outlier. And so if we remove that piece, it's still a little bit skewed, but it's not too bad, especially because our sample size is so large, 632 vehicles. So I'm going to go ahead and first document some of the things we know, because I like doing that. So we have a mean difference. Instead of writing it as D with the bar on top, I just did our regular X bar and gave it this subscript for the difference. And we have a mean of our standard deviation for our sample. And then our sample size is very large. So we're going to say here that using a normal model is appropriate. So we would have to go through the assumptions and conditions. Let's chat about them. You should write them down, but we'll have a chat about them here. We need to always get our information from random methods. They don't mention that these vehicles were selected randomly, but I think we can probably presume that 632 vehicles here are representative of all vehicles. Um, we're taking a big assumption here to say that they are randomly selected, but we will make that assumption just for the sake of doing this problem. We need independence, so we need to know that the differences for the city and highway fuel efficiency for all of these cars should be independent. Well, 632 cars should be less than 10% of all vehicles, and the differences should be independent. It wouldn't make sense to me that the fuel economy of, like, again, a Prius would affect the fuel economy of, an Ford F350. So we should have independence here, and our sample size is very large. So even though we have a bit of skew in our histogram, even after we move the outlier, our sample size is very large. So using a normal model would be appropriate. So we're going to go ahead and we are going to do a paired t-interval. And you should name it paired t. You don't want to say just a one sample t-interval, because that's not what it is. It's a paired t-interval. We are looking at a confidence interval for a difference in two groups. So, but on our calculator, sorry about that, on our calculator, it is going to be the same option that we did for one sample mean. So stat tests, it's going to be a t-interval. We are going to say it's a paired t-interval, though, because we are not just using one sample data. We are using the difference in the two samples. And we'll put our data in. And we can find our interval. Oh, I put a wrong number in. So if yours looks different than mine, that's okay because I put the wrong number in. I said this was 7.97 and said 7.37. There we go. So there's our interval. These are miles. These are differences in miles per gallon. So 7.17 miles per gallon, 7.57 miles per gallon. I'm going to write it like that. This is not an average miles per gallon. This is an average difference in miles per gallon. So that's what we want to say when we make our conclusion. We're not talking about the average mile per gallon. We're talking about the average difference, or the mean difference in miles per gallon. So let me go ahead and write my conclusion, and then we'll talk. So we're going to use the same sort of structure to our interpretation, just making sure that we're saying the right parameter. This time our parameter is not just a sample mean. It is the mean difference. So we're 95% confident about the mean difference in city and highway fuel efficiency. We put our context in there, and it's between 7.17 miles per gallon and 7.57. I think one of the mistakes people make is they sometimes reference the sample in their conclusion. We're not trying to make an interval for our sample. We know the mean difference in city and highway fuel efficiency for our sample. We know what it is. It's 7.37. We are trying to make or draw a conclusion or make an inference about the whole population, about all vehicles and the difference between the city and highway. So don't mention the sample in there. We are trying to infer, again, about the whole population. So we're trying to find the true population mean difference in fuel efficiency. Did we find it? We don't know, but we're 95% confident it's between those two values. As always, I have another problem for you to do, so let me make this a little bit smaller. I hope it's not too small on your screen. If it is, this will be on Canvas, so you can pull up the PDF on Canvas to get the data. There will be some questions for you. Make sure you answer those questions, so watch all the way to the end. If you have questions, as always, please ask, and you get better at this by doing practice. Good luck.